Inverse functions. Consider the function f of x equals y, which is shown on the arrow diagram opposite. This function may be expressed as a set of couples. So we have 1, 5, so 1 goes to 5, 2, 7, 2 goes to 7, and 3, 7, 3 goes to 7. The inverse of this function, written f to the power of minus 1, can be obtained by reversing the arrows, i.e., that is, by switching the first and second components of each couple. So we have f to the power of minus 1, or the inverse of function f, maps y to x. And we get the couples 5, 1. So 5 goes to 1. 7, 2. So 7 goes to 2. And 7, 3. 7 goes to 3. So we had x mapping to y, and now we have y mapping to x. It is interesting to note that, in this case, f to the power of minus 1, or the inverse of function f, is not a function, but merely a relation. This is because there are two arrows leaving the element 7. So here's 7, and there are two arrows leaving it. In maths, functions are far more important than relations, being uniquely defined for every element in the domain. In practice, functions whose inverses are also functions are very useful. So we need to determine the condition under which the inverse of a function is also a function. So for the inverse of the function y maps to x to be a function, there must be exactly one arrow leaving each element of y when the arrows are reversed. For this to happen, there must be exactly one arrow arriving at each element of y under the original function f of x maps to y. But this is precisely the definition of the function f of x maps to y being a bijective function. Thus, the condition for the inverse of f, y maps to x, to be a function called an inverse function rather than just the inverse of a function is that f of x mapping to y is a bijective function. This is one of the main reasons why bijective functions are so important. So suppose f of x maps to y of x maps to f of x is a bijective function. Then f equals x comma y, where x is equal to f of x is an element of x, and y is an element of y. The inverse function, so the inverse function of y maps to x of x maps to f of the inverse of x, is given by the inverse of f being y comma x, where y is equal to f of x is an element of x, and y is an element of y. So all that's really happened here is that the x and y have swapped around. And that is the definition of an inverse function. Our y values now come first and our x values come second. If we are given a bijective function, f, by a rule, we need to be able to deduce the rule of the inverse function. Consider the function f with the rule f of x equals 2x plus 5. If y is the image of x under this function, then y equals 2x plus 5. Now, the inverse of f maps y back to x. To find a rule for the inverse of f, i.e. a way of calculating x if we know y, we can rearrange y equals 2x plus 5 as follows. So we have y equals 2x plus 5 and we want to solve for x. So what we do is we bring the plus 5 over the other side. It becomes minus 5. So y minus 5 equals 2x. And then we divide both sides by 2 to get the x on its own. So get y minus 5 over 2. So we've solved for x. We now have x being the subject of the formula. Thus we can say the inverse of f, y, maps y minus 5 over 2. However, when giving the rule of a function, even the inverse of f, it is usual to let x stand for an element of the domain and y for its image. Thus we prefer to write the inverse of f of x maps to x minus 5 over 2, or y equals the inverse of f of x, x minus 5 over 2. So what's happened is we've swapped the y for an x and the other y for an x. So if we have a look at it on our arrow diagram, or our mapping diagram, it might be a little bit easier to see. So we start off with the function f, and x maps to y, and y equals 2x plus 5. So then what we do is we change the direction of the arrow for the inverse of function f. So we have y maps to x, which equals y minus 5 over 2. And then what we do to finish it off is we swap the y for an x, the x for a y, and that y for an x. So we just change from x to y or y to x. So we started off with the function x mapping to y equals 2x plus 5. This was just the function. To get the inverse of that, we changed our arrow going from y to x equals y minus 5 over 2. So here we had solved for x. We had rearranged the formula so that x was the subject of the formula. And then in the last step, we just swap our y's for x's and x's for y's. So this y became this x. This x equals became y equals, and y minus 5 over 2 became x minus 5 over 2. So let's have a look at an example. So these are the steps that we're going to follow. In practice, the rule for the inverse function can be found from the rule for f of x by the following method. Step 1, write the given function as y equals f of x. Step 2, rearrange this equation to get x on its own. Step 3, switch the x's and the y's. This gives the inverse function. So the function f is defined by f of x maps to 2x plus 1 divided by x minus 1 for all x values that are an element of the real number set except for 1, i.e. all real numbers except x equals 1. So part 1, express the inverse of f of x in terms of x. So step 1, we're going to write the given function as y equals f of x. So f can be written as y equals 2x plus 1 over x minus 1. Step 2, rearrange this equation to get the x on its own. So we want to solve for x. So we're going to multiply both sides by x minus 1 so that we get rid of the fraction part. So we end up with y multiplied by x minus 1 on the left and 2x plus 1 on the right. Y times x is xy, y times minus 1 is minus y equals 2x plus 1. We're going to bring anything containing an x over to the left hand side so that 2x comes over and becomes minus 2x. And then we bring anything without an x over to the right hand side so that minus y comes over and becomes positive y. So we have xy minus 2x is equal to y plus 1. Then we're going to factorize and take out the x as the highest common factor. X into xy leaves you with y. X into minus 2x leaves us with minus 2. And that's still equal to y plus 1. Then we're going to divide across by y minus 2 to get the x on its own. So we end up with y plus 1 divided by y minus 2, which equals the inverse function of y. And then step 3, switch x and y. This gives y equals the inverse function of x. So that x there gets swapped for that y. That y gets swapped for that x. and then both of those y's get swapped for both of those x's in the fraction. Part 2. Express f after the inverse function of x in terms of x. So this is a composite function, and we have to apply the inverse function first, and then we apply the function second, the original function second, which was 2x plus 1 over x minus 1. So it's going to be f after the inverse function of x. So f after the inverse function of x. So what we do is we swap this for the inverse function, x plus 1 over x minus 2, which is what we got here. So that comes inside here. And then we substitute that into the original function. So we substitute that into f, because f comes second. The original function comes second. So we're going to substitute that into the original function, which is also written here. So that x there gets swapped for x plus 1 over x minus 2. And that x in our denominator gets swapped for x plus 1 over x minus 2 as well. So we end up with 2 multiplied by x plus 1 over x minus 2 plus 1 divided by x plus 1 over x minus 2 minus 1. Now we want to see how much we can simplify this. So we have fractions in our numerator and fractions in our denominator. So the first thing we want to do is get rid of the fraction. So we're going to multiply the top and the bottom by x minus 2, because then that will get rid of the fraction. So multiplying the numerator by x minus 2 and the denominator by x minus 2. So 2 times x plus 1 over x minus 2 multiplied by x minus 2. What will happen is the x minus 2's will just cancel. So we end up with 2 times x plus 1 in our numerator. And then 1 times x is x, and 1 times minus 2 is minus 2. Then we do the same on the bottom. We multiply by x minus 2, so that x minus 2 will cancel. And then we're left with x plus 1 in our denominator, and minus 1 times x minus 2 is going to be minus times x minus 2. And then we're going to have 2 by x is 2x, plus x is 3x. Then 2 multiplied by 1 is 2, and 2 minus 2 will just cancel out. So we'll just have 3x in our numerator. And then x minus x will cancel out. And then 1 minus minus 2 is the same thing as 1 plus 2, and 1 plus 2 is 3. So you get 3x over 3, and then the 3's will cancel, leaving us with x. So f after the inverse of f of x is going to leave us with x.